Hey students, welcome to your quiz correction for quiz 2. And our first question, I was actually surprised by how many of us did not get this problem correct. It says the numerator of a fraction is 6. Which of the following could be the denominator of the fraction so that it is already in lowest terms, which means that it cannot be simplified. So they're asking us, which of these can we use to make a fraction that cannot be simplified if we know 6 is the numerator for each fraction? So I could have easily just made a bunch of fractions and checked. So 6 over 9, this simplifies by 3 to 2/3. 6 over 12, this simplifies by 6 to 1/2. 6 over 15, this simplifies by 3 to 2/5. 6 over 18, this simplifies by 6 to 1/3. However, 6 over 19, they do not have a common factor, and so 6 over 19 is the only one that is in lowest terms already. So E is our answer. Okay, let's take a look at problem number 2. They wanted to know what this equals as long as x does not equal 8. The reason they said x cannot equal 8 is because if we put 8 in here, that'll make our denominator 0. We can't have that. So what we're going to do first is, if I know I have to equal this to something and these all look simpler than what we already have, then I want to simplify this. So I'm going to factor first to see if there's anything I can cancel out. So I'm looking for two numbers that multiply to give me 24, but when I add them I get negative 11, and that is a negative 3 and a negative 8. Because a negative 3 times a negative 8 gives me a positive 24. But when I add negative 3 and negative 8, I get negative 11. Okay, so early on when I first started teaching you, I said that there was a trick that you were going to need in a lot of the problems that were going to be on your assessments in order to cancel stuff out. So what I'm talking about is the fact that these two expressions look very much alike, but they are very different from each other right now. So this is a positive 8, this is a negative 8. This is a positive x, this is a negative x. So what I'm seeing here is that the signs are completely opposite. So if I want to get opposite signs, one thing I can do is I can factor out a negative 1, and that flips the signs of what's inside. So now I have a negative 8 and a positive x. And if I wanted to write this in a different way, I can write this as, if I factored out the negative 1, then I can just swap these. This is a positive x minus 8. And so when I do that, I'm able to cancel out this x minus 8. And all we're left with is my mistake right here, which should be an x minus 3, which came from right here. Okay, so that means for our solution, we're looking at x minus 3, but not just x minus 3, because we have to remember what we factored out of that 8 minus x. So we have x minus 3 divided by a negative 1, which gives me a negative x plus 3, or a 3 minus x. And so that answer is G. In problem number 3, we are asked to add these two fractions together. In order to add two fractions together, they need to have like denominators. So currently they do not have like denominators, so we're going to investigate a little bit to see what their denominators actually are, to see if we can fix that. So in our first fraction, we actually have a difference of squares because x squared minus 1 is the same as minus 1 squared. And so we can break this down into plus x and minus x, plus 1 and minus 1. And in the second one, I have an x squared and an x, so I can actually factor out an x there. So I'll write this as x times x plus 1, because x times x will give me x squared, and x times 1 will give me x. So now I can see what my common denominator needs to be. So I need to account for x plus 1, that accounts for this one and this one. If I account for x minus 1, that accounts for this one. But I still need to account for x as well. So I want to make sure both of my denominators equal this. And so if I'm looking at the first one, I have x plus 1 and x minus 1, but I don't have x. So I know that on the top and the bottom, I need to multiply by x. If I look at the second one, I see I have the x plus 1, but I don't have the x minus 1. So I need to multiply top and bottom by x minus 1. And so now I can multiply and combine like terms. So I end up with x plus 2x minus 2 all over x plus 1, x minus 1. And so when I work on simplifying this, x and 2x gives me a 3x minus 2. And on the bottom, if I refoil this back in, I get x times x squared minus 1. And if I redistribute that x back in, I get 3x minus 2 over x cubed minus x. So let's look at our answer choices. I want 3x minus 2, so I know it's not this one or this one. And on the bottom, I want x cubed minus x, so it has to be C. C is our answer. Okay, question number 4 asks us to simplify this expression. This is the division of two rational expressions. So the first thing we need to do is we need to keep, change, flip. We need to keep the first fraction, change division to multiplication, and flip the second fraction. So we end up with x squared plus 2x minus 24 all over x minus 3, and this is now being multiplied by x minus 3 all over x plus 4. So we know that in order to simplify this, we need to factor as much as we can so that we can see factors that are going to cancel out. So if I'm factoring this top portion, I'm looking for two numbers that multiply to give me negative 24, but when I add them I get 2. And this is x plus 6 and x minus 4. Because 6 times negative 4 gives me a negative 24, but 6 plus a negative 4 gives me a positive 2. So I also have the x minus 3 from up here, the x minus 3 down below, and the x plus 4 down below. So in this case, we cancel what we can cancel out, which is the x minus 3, and we're left with x minus 4, x plus 6 on top, and x plus 4 on the bottom, which is the answer G. Let's take a look at our last problem, number 5. They're asking us to subtract these two expressions, and we know whenever we're adding or subtracting fractions, they need to have a common denominator. So in our first expression, we cannot factor this out, so that is the factor of the denominator. In the second expression, we cannot factor that out, so that is the factor of the denominator. So our common denominator needs to account for both of those factors. So 3a plus 5 accounts for this factor, and 3a accounts for the second factor. So this tells me that in order to get this first fraction to match this denominator, I need to multiply the top and bottom by 3a. And in order to get this second fraction denominator to match this denominator, I need to multiply the top and bottom by 3a plus 5. So when we do that, we get 21a minus, distribute that 4, we get 12a, and again this is minus because it's negative, minus 20. So if we simplify this here, 21 minus 12 is 9a minus 20 all over 3a plus 5 times 3a. And so if we look at our answer choices, we actually see that we have our numerator here and our denominator here as well. And so our answer is C.